Okay, so what we're looking at here is a shaft balancing system, and it consists of two air bearings, one there and one there. And these air bearings are made of a graphite block that's been machined into a U-shape, and graphite is unique because it is porous. It's about 15% porous, so air pressure on the underside of it percolates up to the U channel and provides air pressure, which will support a shaft in near frictionless suspension, just like an air hockey table. So by putting two together like this, we can support the shaft at two ends and have a wheel in the center, and then balance the assembly. And we'll see that in a second here, how sensitive this system is. So I'm going to put a shaft on the assembly now, and we'll see how well it does. At each end of the shaft I have a magnet, and then another magnet over here on this tower to oppose the magnet so that it floats, not only floats longitudinally, radially and axially at the same time. Okay, so we can see this. I'll just focus on this end here, and you can see the oscillation of the shaft back and forth as it continues to float on the air bearing with near frictionless support. It will settle out, but it takes a long time. And then also in rotation, it will also rotate for quite some time and then settle out. And in this case, you can see the mere paint, black paint on the end of the shaft appears to be the deciding factor in how the shaft ends up settling out. So it's extremely sensitive to the shaft imbalance. And this is just the shaft. So imagine a wheel that's several inches in diameter. That'll be even that much more sensitive as you move out from the axis of the shaft. There should be even more sensitivity with that imbalance. So once again, if I hold the shaft with the paint at the top and I let go, the shaft tends to oscillate between the high and low spot seemingly forever, until it will settle out where the paint is at the bottom of the shaft. Once again showing amazing sensitivity. We'll try and stop this now to show you how I got to the bottom of the paint now to show you it's still oscillating ever so slowly between the high and low points. This will go on for quite some time. So this system is set up for a 3/4 inch shaft, nominal shaft, but we can make the system adapt to any diameter shaft we want. The only restriction is the shaft has to be quite straight and quite high tolerance, but still shafts of this nature are between $40 and $60. They're not breaking the bank. You can see this is not particularly well surfaced shaft. It's been dinged and beat up quite a bit since the original. But we can machine whatever shape we want in the graphite, so that would mean we can go higher or lower diameter shafts if we want to, and there's no restriction on the height clearance or the width between those bearing blocks, so we can shorten them and lengthen them to what we want, and raise the height of the towers to accommodate larger diameter shooting wheels, that kind of thing. So that's all we need, is to know what those design parameters are to finish this experiment and turn it into a production system.